Hello there, Mr. Sutton here, bringing you the Algebra 2 Honors 7-2 Part 2 homework solutions on graphing rational functions. In this one, we focus on general linear form, including graphing it with finding the asymptotes first, and also rewriting it using long division. For this problem, we're going to start by finding the asymptotes for this one. So we have a vertical asymptote wherever x plus 5, the denominator, equals 0. So that would be at x equals -5. For the horizontal asymptote, we take the ratio of the lead terms. So we have 1 over 1 for the x over x here. So that's just y equals 1 for that. And for my additional points, let me take something to the left and the right of -5, the vertical asymptote. So if I do f of -6, that's 1 to the left of this. That's going to be -7 over -1, which is +7. And now let me go 1 to the right of this -5, so plug in -4. That gives me -5 over 1, so -5. Graphing all this out, we have our x equals -5 vertical asymptote right here, and horizontal asymptote at y equals 1, which is about here. We have the additional point -6, 7, which is up here. And then we have -4, -5 down here. So there's one branch, and there's my other branch. And now for the domain, x cannot equal -5 because of this asymptote. And for the range, y cannot equal 1 because of our horizontal asymptote. To graph this function, let's start by finding the vertical and horizontal asymptotes. So for the vertical asymptote, I can set my denominator equal to 0, so -x plus 10 equals 0. If I just add x over to the other side, I end up with x equals 10 for my vertical asymptote. And then for the horizontal, I take the ratio of the lead coefficients, so that would be y equals -2 over -1, which reduces to +2. For my additional points, let me plug in something to the right and the left of 10 here. So let me go 1 to the left and plug 9 into all that. So this is going to be -18 plus 3 is -15 over +1, so 15, or -15 rather. And then we have f of 11 I'm going to find next, 1 to the right of 10. So plugging 11 into my original, we've got -22 plus 3, which is -19, and that's going to be over -1, so +19 in that case. Graphing all this out, I'm going to make my x grid lines go by 2's so that I can fit this x equals 10 for vertical asymptote. And I've got some big numbers for my y values, so I'm going to make those go by 4's to be able to fit all those. For my horizontal asymptote, I've got y equals 2 right here. Next, let me graph my points. So we've got 9, -15. So here's 9. Here is -15 right about there. And then we have 11, 19. Here's 11, and 19 is all the way up here near 20. So let me graph my lower left branch through that point, and graphing my upper right branch through the other point. Now for the domain, we have to leave out this vertical asymptote, so x cannot equal 10. For the range, we leave out our horizontal asymptote, so y does not equal 2. On this problem, they want us to rewrite this function in transformation form and then graph it. So let's start by doing some long division to get it in that form. So we have 3x plus 5 divided by x plus 1. Doing the x into the 3x here, that's going to go in 3 times. Multiplying that back out, we have 3x plus 3. And now I'll subtract all that stuff. 3x's cancel. 5 minus 3 is 2. So we end up with 2 over x plus 1. That's going to be our main part here, the a over x minus h part. And then we'll have a plus whatever this quotient is, plus 3. So taking a look from a transformation standpoint at what's happening to the 1 over x function, the 2 up here is giving us a vertical stretch. The plus 1 down here gives us a translation 1 to the left, and the plus 3 out here gives us a translation of 3 up. So vertical stretch and left 1, up 3. Let's write out our parent function. That would be the 1 over x function, which I'll just call f of x. So that's going to be -1, -1, and 1, 1. That's our parent table. And then here's the f of x we're talking about too. They spelled it out in the problem. And then for my g of x table, so if I'm going left 1, that means we have x minus 1 for the new rule for that. And the vertical stretch by 3, actually not by 3, by 2. And then going up 3, that's going to be 2y plus 3. So we'll do the x's first. -1 minus 1 is -2. 1 minus 1 is 0. And now for the y's, 2 times -1 is -2, plus 3 is +1. 2 times 1 is 2, plus 3 is 5. For our asymptotes, the vertical asymptote got shifted 1 to the left because of this -1. So we have x equals -1 for that. And we went up 3 for the translation vertically. So that means y equals 0 is now going to be y equals 3 for the horizontal asymptote. Putting all that together, we have our vertical asymptote at x equals -1, horizontal at y equals 3. And then we have the 2 points in our table, -2, 1, which is right here, and then 0, 5 is all the way up here. So here's one branch in the lower left and the other in the upper right. For this problem, they want us to rewrite this in transformation form and then graph it. So we're going to do that by using long division on this g function. So I have 4x minus 11 over x minus 2. Dividing the x into 4x here, that's going to be 4, which I'll put in the constants column. Multiplying that back out, we've got 4x minus 8. And then if I subtract that, 4x is canceled. We have -11 minus -8, so plus 8. That comes out to -3. So this is going to be -3 over x minus 2. And then we'll have a plus 4 for that quotient there. So in terms of transformations, the negative up here gives us a vertical reflection. The 3 gives us a vertical stretch because it's 3 times the function basically. And then the -2 down here is a translation of 2 to the right. The 4 here, we're going up 4 for that translation. So vertical stretch and reflection, and translation right 2, up 4. Our original f of x table is going to be -1, -1, and 1, 1. For the g of x table, since I'm going right 2, I'm going to write x plus 2 for that. And since I've got this -3 and this plus 4, that's going to be -3y plus 4. So let's do the x's first. We've got -1 plus 2, which is 1. 1 plus 2 is 3. And then here we've got -3 for the y times -1, which is 3, plus 4 gives us 7. And then -3 times 1 is -3, plus 4 is 1. Our asymptotes, for the vertical one, we shifted 2 to the right, so now we have x equals 2 instead of x equals 0. And for the horizontal asymptote, we went up 4 in this function, so that's going to be y equals 4 instead of y equals 0. Putting all that together on a graph, we have our vertical asymptote at x equals 2, horizontal at y equals 4. We have the point 1, 7, which is somewhere up here. And then 3, 1 is right here. So we have our upper left branch and our upper left branch and our lower right branch. And that's it. For this word problem, we're told that our school purchases a math software application. Ooh, cool. The program has an initial cost of $500 plus $20 for each student who subscribes. And this is actually a pretty typical way to price these things. So we want to know how many students have to subscribe for the average cost per student to fall to $30. All right, well, the average cost in general is going to be the total cost, including both of these prices, divided by the number of subscribers. So to write the total cost, we have to do the 500, which we're paying no matter what, plus if we have X subscribers, then we need 20 times X to get the price for all the subscribers. So plus 20x. And then the number of subscribers, again, that's just x, so we can just leave that down there. Now to figure out what x needs to be to get this average down to 30, I just need to replace this average with 30 and solve from there. To get this x out of the denominator, I'm just going to multiply both sides by x. So we have 30x equals 500 plus 20x. If I subtract 20 to the other side, that gives me 10x equals 500. And then dividing by 10, we see that x equals 50. So we need 50 students using this software in order to get the cost down to 30 per student on average. Now they want to know also what happens to the average cost as more students subscribe. So they're basically asking, like, if you have 100, 1,000, 10,000 students, if you have like insanely large school, is there kind of a limit on what this average is going to go down to? So to figure that out, we're essentially asking what the horizontal asymptote is for this average function here. What happens as you approach infinity, essentially, for the x value. And to find horizontal asymptotes on these, we just take the ratio of the lead coefficients. Now this 20x would be the lead coefficient if I actually wrote things in order like I'm supposed to. So we're going to end up with 20 over 1 for the horizontal asymptote on this, which is a value of 20. Now that means that as more and more students subscribe, your average value is going to be approaching $20 per student.